Hello students, myself Manuj. So again I welcome you all in my homemade video series of class 11th and class 12 topics. Please pardon the background noise. As you know, this video is being recorded at my home. Okay, so in the previous video, the link you can find in the description, we discussed about average mass and we discussed about vapor density. In this video, we will be discussing something about empirical formula. Now, first of all, what is the meaning of empirical formula? Let's understand that. So, empirical formula is the formula which contains simple ratio of atoms present. The formula which contains simple ratio of atoms present. Okay, for example, let's say C2H6. C2H6 is ethane. It is a molecular formula. Okay, how many carbon we have here? 2. How many hydrogen we have here? 6. So if we take the simple ratio of 2 and 6, so 2 is to 6 equals to how much? 1 is to 3. So if I divide this entire formula by 2, I will get CH3. So CH3 will be called empirical formula. Okay. Take one more example. Let's say C6H12O6. It is glucose or fructose. Okay. Now here 6 carbon, 12 oxygen, hydrogen and 6 oxygen are present. If I divide this entire formula by 6, so I will get how many carbon? 1. 12 divided by 6, how many hydrogen? 2. 6 divided by 6, how many oxygen? 1. So CH2O will be called empirical formula. You're getting the same. So molecular formula and empirical formula are generally different. Molecular formula and empirical formula are generally different. So what happens, but it's not always true. For example, let's say this, C3H6O2. How many hydrogen here? 3. How many hydrogen here? 6. How many oxygen here? 2. So it is a molecular formula. And since I hope you can understand that carbon, hydrogen and oxygen are already present in simpler ratio, so it is empirical formula as well. So for this molecule, empirical formula is same as molecular formula. For this molecule, empirical formula is quite smaller as compared to molecular formula. Okay, I hope you are understanding the meaning of molecular formula and empirical formula. Now, I hope you are understanding one more thing. The molecular formula is nothing but n times empirical formula. Means molecular formula is empirical formula whole n. For example, let's say I said this as CH3 was my empirical formula. If I make it whole twice, so it will become what? C2H6. So this is my molecular formula. This is my empirical formula. And what is this 2? 2 is nothing but n. N is an integer. N is an integer. So relation between MF and EF is MF equals to EF whole n. Now, if you want to calculate n, how can we calculate? N can be calculated as molecular formula weight. Molecular weight divided by empirical formula weight. For example, here what is the value of n we got? 2. Can you tell me the weight of C2H6? C2H6 means 12 into 2 plus 6 into 1, that is 30. What is weight of CH3? CH3 weight will be 12 plus 3, that is 15. So if I calculate this n, so n will come as 30 molecular weight divided by empirical formula weight, that is 2. So it is coming as 2. So this is how we calculate n. And one more formula is there for calculation of n. N can be calculated as number of particular atom present in molecular formula. Number of particular atom present in molecular formula divided by number of same atom present in empirical formula. For example, let's take this. Again, let's take this C2H6 only. How many carbon you can see in your molecular formula? How many carbon you can see? 2. So let's take a particular atom carbon. So how many carbon atom you can see here? 2. How many carbon you can see in empirical formula? 1. So if I take 2 upon 1, so it will give me n. I hope this thing is clear to you. Terms are quite clear. Okay. You have studied empirical formula in class 9th or class 10th in your class 9th or class 10. So let's revise it once and try to solve some basic problems. Okay. Let's take a question, a small question. It says a compound contains 80% carbon and 20% hydrogen. Find empirical formula. Okay. I hope you remember that we used to draw a table. So the very similar table I am going to draw. Okay. What do we write in the first column of this table? Serial number. Okay. So serial number. So first item is, let's say, carbon. What is the carbon percentage it is? It is 80%. Okay. Now, in the next column, what we are writing? Percentage divided by atomic weight. So what 80 divided by 12. 12 is the atomic weight of carbon. Okay. Second atom is what? Second atom is hydrogen. Hydrogen, what is the percentage of hydrogen? 20. What I will do here? I will simply divide 20 by 1. Percentage divided by atomic weight. Hydrogen atomic weight is 1. So here it is coming as, I hope you can see, it is coming as, if I divide it properly, so it will come 4, 20, 4, 3. It is coming as 20 by 3. Okay. And here it is coming as 20. Up to here, any doubt? Okay, very good. Again, firstly you write atom, a percentage of atom. Percentage of atom divided by atomic weight. So it will give you X. In next column, we have to find relative number of atoms. Relative number of atoms. Relative number of atoms means, let's say if I am having 1 rupee, so that person is having 3 rupees. So our relative number is 1:3. अगर मेरे पास 2 रुपए होंगे, if I will have 2 rupees, so that will have 6 rupees. If I will have 3 rupees, that will have 9 rupees, like that. Okay, means you are 3 times having more money as I do. So now we have to find relative number of atoms. How do we find it? We divide X with the smallest of X. So tell me, for carbon, what is X? X is 20 by 3. So this 20 by 3 will be divided by, tell me, this is a value of X, 20 by 3, and this is also a value of X, 20. Who is smaller, 20 by 3 or 20? 20 by 3 is smaller. So divide this 20 by 3 with 20 by 3. What you will get? 1. Okay, see here. Divide this 20 by smallest of X. What is the smallest of X? 20 by 3. How much you will get? 3. So now, relatively, your carbon is 1 and hydrogen is what? 3. So empirical formula will be C1H3 or simply CH3. You're getting this thing? Okay. This is how we draw the table. If you follow these steps, you can easily find the empirical formula. Firstly, atom, percentage of atom, percentage divided by atomic weight. Then whatever number comes here, divide each number with the smallest of these. 20 by 3 divided by smallest 20 by 3. 20 divided by smallest of this 20 by 3. So you got 1 and 3. These are the relative atom presence. Relative atom means if carbon is 1, so hydrogen are 3. So if carbon will be 2, so hydrogen will be what? 6. If carbon will be 3, so hydrogen will be what? 9. If carbon is 4, so hydrogen will be what? For 12. Like that. Okay. So this is the method that you studied in class 9th or class 10th. Okay. There is one more method. If percentage is given to you, so how can you find this empirical formula? Let's see. So you do one thing. Let's say assume weight of compound is equals to 100. Second method I am writing. Second method. Okay. Assume compound weight is 100. So tell me, how much carbon will be there? Weight of carbon. So weight of carbon will be how much? You know 80% present is carbon. So weight of carbon will be 80 gram. Weight of hydrogen will be 20 gram, as you have 20% hydrogen. Okay. Now find moles of carbon here. Moles of carbon will be what? 80 upon 12. And here moles of hydrogen will be 20 upon 1. Now the formula will be, empirical formula will be C 80 upon 12 H 20 upon 1. That's it. Just simplify this. How will I simplify? Divide everything by 20. So if I divide everything by 20, first see, here it is coming 3, here it is coming 20, cancel by 4. So it is coming as C 20 by 3, H 20. Again you can divide it by 20. So it will come as C 1 by 3, H 1. 20, I divided both with 20. Now multiply everything by 3. So I will get C 1, H 3. So formula is CH3. This is my empirical formula. Although, I hope it is clear. What I did, I assumed weight of compound will be 100 gram, 80 gram will be carbon and 20 gram will be hydrogen. I found the moles and simply whatever mole came, I wrote carbon will be 80 by 12, hydrogen will be 20 by 1. Okay. Although I said it is a second method, I hope you understand, I hope you feel like this is a smaller method. But let me tell you one very interesting thing, that this method is not new. This method is exactly the same as we did earlier. This method is exactly the same as we did earlier. There we wrote so much. Here we wrote very little. We wrote just moles of carbon, moles of hydrogen. Simply took the ratio. There we wrote relative number of atoms. There we wrote percentage divided by that, small as, so many things were there. Here we kept our steps small, but we got the very same thing. So if you wish to draw the entire table, you can draw. If you wish to draw just this much, you are free to do this. Okay, let's move forward. Now, let's see another problem. It says in a compound, weight of carbon is to hydrogen is to oxygen is 6:1:8. Means carbon, hydrogen and oxygen have weight ratio 6:1:8. What you have to do? You have to find empirical formula. Now, what I will do in this question? I will not assume the weight of compound to be 100. This time I will assume weight of compound. Remember, if something is given in A is to B ratio, how much we total assume? A plus B. So here I will assume weight of compound equals to 6 plus 1 plus 8. How much? 6 plus 1, 7, 7 and 8, 15 gram. Okay. Now out of this 15 gram, I will divide 3 portions. One portion will be for carbon, one will be for hydrogen and another will be for oxygen. Tell me, how much weight of carbon I will have? WC. WC will be 6 gram. Carbon has 6 ratio, na? What will be W of hydrogen? 1 gram. What will be W of oxygen? 8 gram. Okay. Now, how many moles of carbon I will have? Let's write here moles. Here moles will be 6/12. Here moles will be 1/1. Here moles will be 8/16. 6/12 means half. 1/1 means 1. 8/16 means half. So, empirical formula will be C half H1 O half. Just simplify it by multiplying 2. Let's multiply everything with 2. So, I will get C half into 2 H1 into 2 O half into 2. So, it will give me CH2O. This is my empirical formula. That's it. Again the same. Why I assumed here 6 plus 1 plus 8? Because ratio and percentage. Do you know percentage is also a ratio, na? So what I used to do here? But sum of all percentage is 100. So similarly sum of all ratio I will take. Here it was 15. Like that I solved it. Okay. This thing is clear? Good. Let's move to the second part of same question. Now, second part of this question is, if molecular weight of compound is 60, so find molecular formula. Okay, pause the screen, give it a try. Or, I hope you remember we found empirical formula is CH2O. This is empirical formula. So, what is empirical formula weight? Empirical formula weight is how much? It is 12 plus 2 plus 16. 2 hydrogen are there now. So, it will come as 30. This is empirical formula weight. So, N will be equals to what? N will be equals to molecular formula weight divided by empirical formula weight. How much it is coming? 60/30. 60 they have given molecular formula weight. 30 I found empirical formula weight. How much N is coming? 2. So, molecular formula will be what? Molecular formula will be empirical formula whole twice. Remember, here we used to write whole N. So I will write here CH2O whole twice means C2H4. This will be what? Molecular formula. Clear? Moving forward. The next question is, in a given compound, weight ratio of carbon, hydrogen and oxygen are 12:3:8. So if upon combustion of 1 mole of the molecule, 2 molecule of CO2 was produced, find molecular formula. Okay. Again, weight ratio of carbon, hydrogen and oxygen are given to you. Now you have to find molecular formula. But for finding molecular formula, they have given one information. That information is, if upon combustion of 1 mole of your molecule, 2 moles of CO2 are produced. So you have to find molecular formula. Please try to find empirical formula on your own. Pause the screen and give it a try. Okay, if you wish to find both, you can see. Fine, let's see. This time I will assume the weight of compound equals to 12 plus 3 plus 8. How much? 12, 3, 15, 15 and 8, 23 gram. Now out of 23 gram, I will again divide 3 parts. First part will be for carbon. First part will be for carbon. How much? Carbon will be 12 gram. Second part will be for hydrogen. So W of hydrogen will be how much? 3 gram. And third part will be for oxygen. Weight of oxygen will be 8 gram. Next step, moles. So moles will be what? 12 upon 12 here, 3 upon 1 here, 8 upon 16. This is how we find moles. So it will come as 1, 3, 1 by 2. So empirical formula will be what? C1H3 and it will be O half. C1H3O half. Okay. Now for finding molecular empirical formula, multiply everything by 2. So it will give us C1 into 2, H3 into 2, O half into 2. So it will give us what? C2, H6, O1. So this is the empirical formula, C2, H6, O1. Okay, empirical formula I hope you have found out on your own. Okay, and now they have given information. They have given information regarding N. If you can utilize that, let's see, can you do it? Now what they are saying, I am training here in order to make the space. They are saying if I do the combustion of 1 mole of compound, so it gives me 2 moles of CO2. Means, suppose formula of my compound is CXHYOZ. Okay, whatever the molecular formula, let's assume this. If I take here its 1 mole, so it gives me CO2. It gives me CO2. And now how many moles of CO2 it is giving us? It is giving us 2 moles of CO2 as it is saying. See, 1 mole of compound, 1 mole of compound giving us how many moles of CO2? 2. We're getting the same. Okay. So since I am getting 2 moles of CO2, so can you tell me moles of carbon in compound? Can you tell me? Think about this. Moles of carbon in compound will be how many? Let's see. Each CO2 contains 1 carbon. Each CO2 contains 1 carbon. So how many moles of CO2 are being formed? 2 CO2. So 2 CO2 will contain how many carbon? 1 CO2 contains 1 carbon. So 2 CO2 will contain 2 carbon. So whatever number of carbon are here in CO2, let me write. Number of carbon in CO2. What is the source of number of carbon here? Source is your molecule. So it will be equal to number of carbon in compound. Are you getting this? So since you are getting 2 moles of CO2, which means 2 into 1 carbon. So these 2 into 1 carbon are coming from carbon of compound. That means your compound contains how many carbon? Compound contains 2 carbons. Are you getting the same? If your compound had 4 carbon, so you know how many moles of CO2 will be formed? 4. If your compound contains just 1 carbon, so how many moles of CO2 will be formed? Just 1. Since you are getting 2 moles of CO2 on combustion, that means you have just 2 carbon in your molecule, because each carbon forms 1 CO2, so 2 carbon will form 2 CO2. So your carbon compound contains carbon 2. Okay. Now tell me, what was your empirical formula? Empirical formula was C2H6O. How many carbon are present in your empirical formula? So here number of carbon equals to 2. Okay. Now I hope you understand. One more formula of N was there. The number of particular carbon, particular atom in MF divided by number of same atom in EF. Remember this formula. So what I will get here? I will get 2 upon 2, that is 1. So what will be my molecular formula? Molecular formula will be empirical formula, whole 1. So I will get C2H6O whole 1. So molecular formula will be C2H6O. This is your molecular formula. This time molecular formula and empirical formula are same. Okay, clear about? Very good. Let's move to the next question. Now next question is 15 gram of a compound gives 6 gram of carbon, 1 gram of hydrogen and 8 gram of oxygen upon analysis. If we performed an analysis upon a compound, we took 15 gram of it. It gave us 6 gram of carbon, 1 gram of hydrogen and 8 gram of oxygen. What they are asking, if vapor density, VD means vapor density of compound was 30, find molecular formula. Okay, pause the screen and give it a try. So how will I do? They have given weight of compound is 15 gram, so let's take 15 gram directly. No need to assume this time. So 15 gram of compound contains 6 gram carbon, 1 gram hydrogen and 8 gram oxygen. Okay, again same step, moles, 6 by 12, 1 by 1, 8 by 16, half, 1, half. So empirical formula will come as C half, H1, O half. Don't leave it like this, simplify it. It is not a simple ratio. So I will multiply everything by 2. So C half, why? Because whatever C, we multiply with the LCM of the denominator. So LCM of 1, 2 and 2 is 2. So multiply it with this. H1 into 2, O half into 2. So it will come as C H2O. Okay. Now, what is the use of giving vapor density? Why they have given vapor density to us? They gave vapor density to us just to find molecular weight. So how can I find molecular weight with this vapor density formula? So I hope you remember the vapor density is equals to molecular mass divided by 2. So vapor density is 30. So that implies 30 equals to m by 2. So what is molecular formula? Molecular weight will come as 2 into 30. That means 60. Okay. Now I am leaving this question on you. You have to find molecular formula on your own, and let me tell you, answer will come. Molecular formula will be C2H4O2. But you have to find this on your own. Okay. So in this, up to this video, we have discussed everything about what is mole. We have discussed its formulas. We have discussed about molarity, concentration terms, everything. We have also discussed about vapor density. We have discussed about average mass. Now from next turn we will start discussing stoichiometry. Okay, so till now, if you want to go through the previous videos of the very same topic, link you can find in the description. Your task will be to solve all the questions based up to this concept, whatever textbook you are following, whether it is NCERT or it is your school textbook or any special book. You need to solve the question, and doubt you can ask me in the comment section. Okay, see you in the next video.